We're now going to take a look at the actual construction of packets and data that flow through TCP/IP. Now, while we use the terms segments and packets and datagrams and data interchangeably, those terms don't mean the same thing for the same data unit as it travels through the OSI model and the TCP/IP stack, although you will hear them used interchangeably. Segments and packets are different terms for different units of data, as we've discussed before. So, in accordance with that, their data construction is a little bit different, although they all have some common construction architectures and terms with them. Now, segments and packets are measured in terms of bytes, numbers of bytes per packet or per segment. And these can be variable lengths. They're not all the same length depending upon what it is, whether it's a TCP segment or a UDP datagram or an IP packet or whatever. But again, they have some things in common. All have headers, of course, that consist of different fields. Now, these different fields have different things in them that do different things for the packet or segment or datagram. And these fields are different lengths in bytes. They're not all the same lengths. Now, some headers will vary between different kinds of packets, such as a TCP segment will have different headers than an IP datagram, of course. Now, they all have data areas, and these data areas come after all the headers. The headers are basically for administrative overhead to get the data where it needs to go. Now, all packets and segments and so forth are measured in terms of bytes, and what you have is a bit offset, and that marks the beginning of the field. Now, the entire packet or datagram or segment starts at 0. Of course, it does not start at 1, and then a given field starts at bit offset X or bit offset Y, for example. Now, fields within these packets and datagrams and segments can also be in common, although not all of these different data units have all the same fields. Fields can include the source address, which is where the data came from, the destination address, where it's going to, the time to live for the packet or data unit. They can also include flags, and flags may turn bits off and on so that the packet or datagram does different things depending upon what flags are set. There's also usually a protocol field that will tell you what protocol is being used, and that tells the receiving end which protocol is being used. There also may be a checksum. A checksum is a number generated to ensure that the integrity of the packet, to ensure the integrity of the data that goes through, and if the checksums don't match on the opposite end, then we know that the data got damaged or somehow the integrity was violated. Then there's the data area, and that comes again after the headers. Now, the data is kind of interesting in that each layer receives data from the layer above it, and to that particular layer everything is data, and then it adds a header onto it. But this data actually contains the header from the previous layer as well as data from the layer above it. So that's how the encapsulation process works. It goes down from layer to layer to layer, and each layer gets data and adds headers on it, and then when that goes down to the next layer, that header and data is considered data itself to the next layer. I'm going to give you a couple of examples of IP packet diagrams and TCP segment diagrams just to kind of show you what's in there. We're going to go more in depth on these as we go through the course later. Just so you can kind of see how this is built, you've got different fields in here, and again, these fields are different based upon which protocol you're looking at and whether it's a segment or a packet or a datagram or whatever. You've got the bit offset as 0. Then, for example, you've got bits 0 through 3 is the version, 4 through 7 is the header length, 8 through 15 is the type of service, and so on. But some of the common fields you have in here: time to live, protocol, checksum, source address, destination address. A lot of different protocols carry those particular fields. And again, we're going to go more in depth on these as we go. This is an example of a TCP packet diagram, and as you can see, it looks almost the same. You have the bit offsets and different fields that start in different bit offsets. But some of the fields are the same, as we saw in the previous example, such as source address and destination address. Some of the fields are not, such as sequence number and acknowledgement number. Those flags in particular are unique to TCP segments. And again, we're going to go more in depth on these as we talk about each protocol separately. But this just gives you an idea of how packets and datagrams and segments are constructed. And this is important to know when we do packet analysis.